We're all aware that space is immense. It's massive. There are many things we still don't know about, but we are gradually learning new things, and each day we grasp onto something new. The search for undiscovered planets is ongoing, and each new discovery provides us with additional information about the uncharted cosmos. Astronomers have identified a second supersized moon orbiting a Jupiter-sized planet beyond our solar system. If verified, the discovery might indicate that exomoons are as prevalent as exoplanets in the cosmos, and that such moons, large or tiny, are a characteristic of planetary systems. However, there may be a long wait. The first confirmed sighting of an exomoon 4 years ago is still pending confirmation, and verification of this newest contender might take just as long and be as controversial. So what are exomoons? How are they detected? Exomoons are moons that exist outside of our solar system. They orbit exoplanets, which are celestial bodies outside our solar system. The first ever sighting of an exomoon in 2018 has yet to be confirmed. In contrast, there are 4,905 verified exoplanets in 3,629 planetary systems, with many more still to be discovered. The prefix exo is derived from Greek and means outside, exterior, or external. We know that exomoons are thought to exist around numerous exoplanets. Exomoons cannot be identified using Doppler spectroscopy of the host star, despite the enormous success of the planet seekers using this approach. This is because the altered stellar spectra caused by the existence of the planet plus more satellites would behave exactly like a single point mass traveling in orbit around the host star. Finding a moon or even a planet hundreds of thousands of light years away from Earth is anything but simple. Moons and planets can only be seen indirectly because they pass in front of their host stars, causing their light to decrease. Using a telescope to capture one of these transient transit signals is difficult, as is analyzing the light curve data. Because they are smaller and block less light, exomoons are even more difficult to detect than exoplanets. As mentioned above, when an exoplanet moves in front of the host star, there is a tiny dip in the light received from the star. Currently, the transit technique is the most successful and responsive approach for discovering exoplanets. The occultation effect is more proportional to the square of the planet's radius. Both a planet and a moon should cause a drop in the observed light if they pass in front of a host star. A planet-moon eclipse may possibly occur during the transit, although such events are extremely unlikely. Transits of an exomoon may be seen if the host planet is directly photographed. A tiny drop in the light received from the directly imaged planet may be seen when an exomoon passes in front of the host planet. The transit probability and occurrence rate of exomoons of directly observed exoplanets and free-floating planets are expected to be high. Moons as tiny as Io or Titan should be observable using the strategy with the James Webb Space Telescope, although this search method takes a significant amount of observation time. Well, onto the main part. The finding was led by David Kipping and his Cool Worlds lab at Columbia University, which previously revealed the first exomoon candidate in 2018. Astronomers have discovered over 10,000 exoplanet possibilities so far, but exomoons are significantly more difficult, said Kipping, who has spent the last decade looking for exomoons. It's actually rather intriguing how this new planet was discovered. The planet's data was discovered concealed in NASA's test data by Tom Jacobs, a retired US Navy officer. Jacobs has long been a citizen scientist or a volunteer who searches NASA telescope data for hints of planets beyond our solar system. Jacobs assisted in the discovery of the gaseous planet presently known as TOI 2180b, led by analyzing test data. Jacobs and his team of citizen scientists, together with 2 expert astronomers known as the Visual Survey Group, and they utilize a tool called LC Tools to visually review telescope data. However, learning more about the planet and specifics such as its size and mass needs the assistance of both professional astronomers and citizen scientists. According to the Astronomical Journal, the Jupiter-like planet orbits a star with the same mass as the Sun and has a 261-day year, which is longer than that of any known gas giants beyond our solar system. TOI 2180b is claimed to be the same size as Jupiter, but nearly 3 times more massive. It's also thought to have 105 times the mass of Earth, as well as elements heavier than helium and hydrogen. The massive exomoon candidate was discovered circling the planet Kepler 1708b, which is about 5,500 light-years away from Earth in the direction of the Cygnus and Lyra constellations. It has a diameter of more than 20,500 miles compared to Earth's diameter of 7,900 miles. The new contender is around 1/3 the size of the Neptune-sized moon discovered previously by Kipping and colleagues, circling a comparable Jupiter-sized planet Kepler 1625b. According to Kipping, both supermoon candidates are likely comprised of gas that has accumulated because of the gravitational attraction induced by their massive size. If one astronomer's theory is right, the moons may have begun life as planets before being dragged into the orbit of a larger planet, such as Kepler 1625b or 1708b. Both moons are positioned distant from their home star, where gravity has less of an effect on planets and moons. In fact, in their quest for exomoons, the researchers searched out cold, big gas planets with broad orbits exactly because the analogue in our own solar system, Jupiter and Saturn, have almost 100 moons between them. Astronomers are fascinated by exomoons for the same reasons that exoplanets are. They may show how and where life may have originated in the cosmos. They are also fascinating in their own right, with scientists curious about how these exomoons arise, whether they can support life, and what role, if any, they play in making their home planets habitable. At least 2 peer-reviewed studies on the habitability of exomoons has been published. Moons that are closer to their planet than the habitable zone are inhospitable. Renee Heller and Rory Barnes investigated the effects of stellar and planetary light on moons, as well as eclipses on their orbit average surface lighting. They also saw tidal heating as a danger to their capacity to live there. The present study examined a selection of the coolest gas giant planets discovered by NASA's Kepler planet hunting mission. After thoroughly screening 70 planets, scientists discovered just one candidate, Kepler 1708b, with a moon-like signal. Observations from other space observatories like Hubble will be required to confirm the discovery, which may take years. Kipling's initial exomoon finding is still being contested 4 years later. In a recent publication, he and his colleagues demonstrated how one group of critics' calculations may have overlooked Kepler 1625b's moon. Meanwhile, Kipping and colleagues are looking into additional lines of evidence. Eric Agol, an astronomy professor at the University of Washington, is skeptical that this recent signal is genuine. It may just be a data fluctuation caused by the star or instrumental noise, he explained. Others seemed more enthusiastic. This is science at its finest. We locate an intriguing object, make a forecast, then either confirm or rule out the exomoon possibility with future observations, stated Michael Hipke, a German independent astronomer. But the quest is worthwhile, according to Kipping, who recalls how the discovery of exoplanets was met with the same suspicion that exomoons are now. Those planets are foreign to our solar system. However, they have transformed our knowledge of how planetary systems arise, he remarked. Will such discoveries help us realize how little we are in this vast universe? What do you think of exomoons that scientists have discovered so far? Please leave your comments in the box below. It will help us improve our content in the future. Subscribe to our YouTube channel to stay up to date on these kinds of videos. Click the bell symbol to receive notifications when we publish new content. I'll see you in the next one.